Hey everyone, welcome back. This will be episode 8 of my robot industrial programming robot videos. Basically, we made this robot. Let's see if he'll run still. He went and we made him push his own e-stop button, which is probably the worst thing a robot can do because he's just killing his own power. But since this is the virtual world, it doesn't do anything anyway. So, um, I guess, I went through configurations in the last video a little bit quicker than I had really intended to. I wanted to spend a whole video just talking about them, but I'm getting tired and I don't want to do it. Um, Basically, the gist of what I wanted to get across, though, that I really didn't in that last video is that, if your configurations in a given path vary wildly between the two, so like this target 10, I've got this fat, boss filled um, section here of the robot, and then I go to this other one, path target 20, and I've got this little skinny side here. There's a whole lot of wrist motion happening there. And so specifically, if this is a linear move instead of a joint move, what it's going to do is it's going to keep that point of the tool there, but get the wrist from this orientation to this orientation. So what that means is that the robot's going to be cruising along and do like a woo, which is pretty much always a really awful bad thing. I mean, you could have, $50,000 worth of equipment out on the end of this robot. And so if he decides he's going to quickly do that, he's going to try to keep that same linear tip speed as he's going. So if he's going 100 millimeters a second, and all of a sudden the configuration between 2 points changes, he flies around and tries to go the other way, but he has to haul ass to do it. And so he's going to jam your stuff right into the part. And I've actually done that a time or two and got out pretty lucky actually on what broke, but that's how it goes sometimes, but you need to be real careful when you're creating these configurations to make sure that they match. And one good way to do that in ABB is when you create let's create like a new path, add to new path here, right click it, configurations, auto configuration. So typically I'll go set the first one to an actual configuration that I want, and then I'll do auto config. And so he's actually gone in and fixed the configurations for these points. And now this one's configured properly, so no crashing is going to happen there on a linear move. So that's important. That's something that I wish was sort of, I mean, I had heard it, but I hadn't really seen what happens. And even in simulation here, it doesn't always do it. It'll say robot configuration error. But if you actually sync that over and run it on the real robot, it'll try to do it, which is the opposite of what you want. I'd rather see it in sim and have it not run it on the robot. But either way, that stuff isn't checked. It just you can do things. You can go to extents to check that sort of thing, but by default, it's going to do whatever. It's pretty crazy. But anyway, some robots, some other manufacturers may handle that differently. I know Fanuc can get in some bad situations like that too. So just keep an eye out for that. There is something here called conf-L. And conf-J its counterpart, but conf-L monitors the configuration during linear movement. And so what that means is you got to be careful with this, but if you do a joint move and then you're doing a whole bunch of linear moves around a part and you don't really want to worry about the configuration, you can actually turn configurations off. So what I could do is before I get to this e-stop, I could tell it conf-L. Conf-L, whoops, off, and then I'd have to turn it back on. But in between two joint moves, he can go, a joint will, if conf-L is on, which is monitoring positions, it's going to go to this exact configuration here defined in the point. So you're going to know that the robot's there. You're going to know every wrist is at the right point or the known point for when you first taught that point. But if you do a whole bunch of linear moves around that area, you should be good, and it'll handle the config and keep it from flipping over if you turn off conf-L. So I don't know what the other robot manufacturers have for this, but it's definitely worth knowing. Another thing that's similar to that that's worth knowing that I kind of wish I looked at more when I first got started is singularity area or sing area, and it sort of allows it to handle these singularities where there's more than one solution for or no defined solution for a position, which is usually like right when the wrist is perfectly straight and things like that. It can't figure it out, and so you know, it's some deep mathematics that I'm not terribly up on. So you can have these separate options here, and it'll say, well, just basically do your best. So you say sing area wrist, uh, um, and that will tell it, hey, right now or just for these points, you're okay to sort of, you know, get as close as you can as you pass through that singularity. And I've found that it's not that big of a deal in a lot of cases. Um, if you need that perfect linearity on every axis for the linear move, then you need to do a joint move in between to let it switch around configurations or get past that singularity, or you know, put your part in a place in the robot's work envelope where he's not in a singularity, or you know, the joint is the wrist is bent or you know, completely defined in all axes. So it's just something else to think about and to know about. It's one of those learning kind of things that uh, you figure out as you mess with this stuff and get strange errors. It's kind of hard to teach it, but um, so anyway, that was the stuff I sort of missed. I think I would like to finish out um, by making another work object and running another part. So this video has kind of gone long already, just kind of recapping all that stuff and with configurations and all that. So I'm going to start a fresh one and we're going to make work objects. So join me for that one.